So sometimes when you're trying to solve for a triangle, which means you're trying to find all of the side and angles given three different things, sometimes you have what's called an ambiguous case. Ambiguous means that the number of solutions is not necessarily always the same. That's one way to think of ambiguous. Another way to think of ambiguous is it's unclear. So, and that's exactly what we have here. When we have a triangle, it's unclear whether it's a triangle that it's just a single triangle, or if you could actually make two triangles out of it, or if there's really no triangles that have these three characteristics. So let's talk about how to find this. So the first step to do, and this is what I always teach people, is to draw your two lines of your triangle like this, and draw one of them from the horizontal position out, and draw this angle. Try to draw this angle right here, angle B, as accurately as you can. So when I draw angle B, I want it to be about 34 degrees, which is like a third of the way up to 90. Okay, and then also you want to draw the side lengths roughly accurately. So A, we're going to call this side A. A equals 4. Always call that. This is always the angle that you know right here. The angle that you draw is always the angle that you know. Here's B, which is 34 degrees. And that's the side that I know. And the other side that I know is across from B. So this side down here is the side that I'm actually not sure about. So I'm going to make it a dotted line because I don't know how far it's going to go. But I do know that A is 4, and I know that B across from A is 3, which is less than 4. So 3 is maybe something like that. So here's B equals 3. But the problem is this. Who says that B couldn't be in here? It certainly could be inside there. That's why it's ambiguous, because you can't tell if there's one solution or two different solutions. The two solutions here would be this triangle that satisfies all the properties, and let me change colors, and this triangle that satisfies all of the properties that are given right here. Okay, so how do you know? Let me go back and show you how you know. The way you know is you find this distance right here. You find the height, which is this distance right here, the altitude, or the height. If I can find that right there, then that's going to tell me how many triangles I'm going to have. So that height, I'm going to call it H. H equals, let's think about what H equals. Well, notice that I have an angle here, and now I have a right triangle. So I can use right triangle trig, and that's the opposite. So the sine of 34 degrees equals the opposite, which is H, over the hypotenuse, which is 4. So what does H equal? 4 times the sine of 34 degrees. Punch that into your calculator. 4 times the sine of 34, which is approximately 2.23, 2.24. Since that height right there, 2.24, is smaller than B, that means that B could either be outside here or it could be inside here. Alright, so now let's talk about, so this in this particular instance has two solutions. So let's talk about how you find what those solutions are. So the first thing that you do is you're going to use the law of sines. So the sine of 34 over the side opposite of it, which is 3, equals the sine of A, which we don't know, A is down here, over the opposite of it, which is 4. Now some people might say, well, why isn't it this angle right here? Well, the reason is because when you take the sine inverse, you're not going to get an obtuse angle, you're going to get an acute angle. So that's why you know it's going to be that angle right there. We can solve for this obtuse angle then. Notice that that angle A is the same as that angle A right there. So we're going to solve for that obtuse by subtracting it from 180, and that'll give us that bigger angle for your second triangle. So solving this for A using your calculator and the sine inverse, you get Your answer is 48. We'll round it to 2 decimal places. 48.21 degrees. So that's this A right here. So that's, I'm going to call that A1 because that's triangle 1. Triangle 1 is my bigger triangle out here. And then you can find all the other ones by using the law of sines. I'm not going to go through and do that for the sake of time. A2, let me change colors here. A2, which is right here, that right there is A2, A sub 2, A for the second triangle, is going to be, if you follow what I said before, that angle right there is the same as A. So the A2 is 180 minus that angle. So what's A2 equal? 180 minus that? 131.79. And then again, you can find all of the other sides and angles of this triangle by just using law of sines and properties of triangles and so forth. So that's called the ambiguous case. Notice in this case there was 2 solutions. Well, let's think about another situation. What if they told you that B here, instead of telling you that it was 3, what if they told you that B was 2? What would that mean? Again, if you look at your H here, you'll see that H was bigger than 2. So if you try to draw this side length down to complete that triangle, if you try to draw the side length down, it's not going to reach, because this distance is 2.24 and this distance is only 2. If I try to make this reach to the bottom, it's just going to swing and it's never going to touch. So in that case, there would be no triangles. You would say no triangles. And what if they told you that B was, instead of telling you that it was 2, what if they told you that B was, let's say, 5? If they told you that B was 5, notice it's bigger than H, so you're going to be able to make 1 triangle, but you can't make 2 triangles, because if you were to try to put that side length 5 is greater than the side length 4 right here. So you couldn't swing that back on the inside here. When you're trying to swing that, you would have to go outside of that triangle and you'd lose that B angle there. You wouldn't have that B angle anymore. So there's only 1 triangle when B is bigger than A. If you're given angle B, when side B is bigger than side A, you know it's not really ambiguous. There's just 1 triangle. It's the longer side right there.
Okay.
So one of the keys is to find H when you're using an ambiguous case, solving with law of sines, solving for a triangle.